The last quantitative technique that I'm going to be talking about is learning curve. And what is learning curve? This is just a statistic tool that shows that the completion time can actually reduce when task is repeated. And I'm sure you can relate with this. When you perform a task repeatedly, you will discover that you spend less time every time you repeat that task. And what is the general rule? And that's where I'm going to start. The general rule about this. This is very common in exam, so you have to really pay attention and make sure you understand it. Most time they test this. So the general rule is that as cumulative production doubles, you expect the cumulative average time per unit to reduce at a constant rate. Let me try and put it down for you so you can see what I'm talking about. So as cumulative production, that is the output, doubles. So which means if you used to produce 1, you double it to 2, from 2 to 4, from 4 to 8, from 8 to 16. What do you expect? We expect that the cumulative average time per unit, we expect that to also reduce. So that reduces, and that reduction will be at a constant rate, that is percentage. And that will happen until, so there is a cap possibility, because there will be a point where the learning will not have any impact on time, or probably there is nothing to even learn again. So until there is no more impact. And when there is no more impact of learning, then that means the last time we achieve that reduction, whatever number of hours we spend to produce will be the time taken for the additional units that we are producing, because there is no more learning, or whatever we are learning does not have an impact on the efficiency. Yeah, but the general rule is that as we double our output, then our time consumption, on the average, is expected to reduce at a constant rate. And that constant rate is the learning curve rate. So which means we're going to be learning a lot of calculations in this particular concept. This general rule, what does it mean? There's a formula for it, but you trust me, I want you to have a good understanding before we go into a formula. So I'm going to use an illustration to explain this. So let's say 100 hours, you would need to produce the first unit, right? And let's assume that the learning curve rate, which usually is denoted as R, let's assume is 80%. So what does this mean for this general rule? 80% learning rate, and it's taking 100 hours to produce 1 unit, the very first unit. Let's find out how long it's going to take to double this production output. So I'll do a table. Let's say we have the cumulative unit here. So we'll say the first one, 1 unit. Then the question is, what is the average time, the cumulative average time that we're talking about, that we expect to reduce at a constant rate? Yeah, remember this. That's what I want to put in the second column now. Yeah, we need to calculate that. So for the first unit, it's going to be 100 hours. And in total, cumulative time taken will be 100 times 1, and that will be 100 hours as well for the first unit. So how many extra units has been made? Because we are coming from 0. So the extra unit is still going to be 1. and the extra time taken to produce that extra unit will always be 100 for this as well as our first unit. Please pay attention. This should not give you any too much stress. Yeah, and we have the average time on the extra unit. Yeah, so I want to use this table to just explain learning curve to you so that even when you start using the formula, you understand what you're calculating, because it's extremely important you're able to apply the formula. Yeah, however, I want you to understand what we're talking about first. So we said the first unit is going to take 100 hours. So which means cumulative time to produce that will be 100 times 1, and that is 100. So the extra unit we're talking about is 1, and the extra time is taken it is 100. And average time for that extra unit is 100 divided by 1, and that will be 100. Now, if we double this 1 into 2, if the learning rate is 80%, which is what we are saying, it means that the average cumulative time to produce these 2 units will be per unit. Remember, this is per unit. The average cumulative average time per unit. Let's not forget that. Remember, this per unit. Right, we're expected to reduce at 80%. So which means it should be 80% of 100, and that means it's going to be 80 hours. Right? Calculate 80% of 100. And that means the cumulative time to produce these 2 units, since average per unit is 80, will be 80 times 2, and that will give us 160. How many extra units we have produced? We produced 1 extra unit because from 1 to 2. We doubled, however, the extra is just 1. And if the first unit that we produced, this one, took us 100 hours, then it means that if we spent 160 hours to make the second one, to double it, then that means the extra one has only taken us 60 hours. And in that case, the average time to produce that extra unit is just 60 per unit. If we double these 2 into 4, and still our learning rate is a constant rate, remember 80%, then that means it will be 80% of 80, and that will be 64 hours. And if we multiply 64 by 4, it will give us cumulative time of 256 hours. The extra unit we have produced from previous time will be 2 units because we have moved from 2 to 4. And extra time to produce those 2 units will be 256 minus 160. And that will give us 96. So if you had spent 96 hours to produce this extra 2 units, it means for each extra unit we produce, we spend average of 48 hours. And that is how it goes on and on. If you can double it to 8 again, the average per unit will go down again at 80%. So we expect it to also reduce by 80%. So which means we're going to have 80% of 64, and that will be 51.2. So it's going to just take 51.2 hours per unit to produce 8 units. And the total, if you multiply both 8 times 51.2, you have 409.6. So that's the cumulative time to produce 8 units. And in that case, we produce extra unit of 4 because it used to be 4, and now we've doubled to 8. So 8 minus 4, that's 4 extra units. And how many hours did it take us to produce 4 extra units? That's 409 minus 256, and that will give us 153.6. And per unit of the extra 4 we produce, that's 153 divided by 4, and that will be 38.4. You can see average time keeps reducing, and you can see here. Yeah, but this is the column where the learning rate is usually applied. The learning rate of 80%. This is where we keep applying it. So that is what we are talking about in terms of just the logic behind it. But let's talk about how it can be used, because in exams, you don't need to do this table. I just use this table to explain to you. In exam, you will need to use the learning curve formula. And why do we usually use this? Why do we need this? We need it because in our forecasting, we always need to calculate labor cost. And remember that labor cost is equal to labor rate, which is the cost of the labor multiplied by the hours of labor. So to determine these hours, definitely we need to be able to estimate it correctly. And that is where learning curve usually helps us to do. It can also be used to calculate the labor cost itself. But usually we'll focus on labor hours because we have the labor hours, we can know the labor cost, right? So that is why it is important for us to know how to estimate those hours. But how are we going to do it? How is it done? Like I said, we are not going to be using this table in exams. So we'll need to use a formula that is written as y equals to ax raised to power b. And what does this mean? Let me explain first. A is just talking about the time for the first unit. Sometimes it might be in batch, so first unit or batch, whatever the question is giving you. But the first output, the time is taking you to produce the first output is your A. X is the cumulative output. Cumulative output. Like if you look at the table that I use as an example now, our cumulative output is the first column here. So this is X. That's what we're saying. And B is called the learning curve coefficient. So this is a coefficient which you won't find anywhere, but you have to calculate it, and that is calculated as log r divided by logarithm of 2. So some mathematics there. Yeah, r, you already know, r is your rate of learning. So you're learning at, for instance, at 80% with this example that I gave you initially. Okay, so now what is y? Y is the most important thing there, and y is just your average time. So the average time per unit in a batch of X, in any batch of X. So take for instance, what we're saying is, if you look at this table that I've given to you, we have, this is our batch of X first column. Yeah, this batch of X. This is the cumulative average time per unit. This is our Y. That's what we are saying. Yeah. So knowing this formula now, let's just apply it on this table and see whether we'll get something similar. So take for instance, let's test it for 8 units. So let's see how much or how many hours will it cost to actually produce 8 units. So 8 units. So we want to calculate the cumulative hours to produce 8 units. So remember we said the formula is y equals to ax raised to power b. And if that is the formula, it means that we need to know what b is. So we know a because a will be 100 hours in that example, remember? X is the cumulative production we're talking about, which is the 8 units here. So our X will equals to 8, but we don't know B. So B, we said, is log R divided by log 2, always constant. So which means you need to press log of 0.8. Remember, R is the learning curve, and learning curve rate is 80%. So log 0.8 divided by log 2. And if you press that, that gives you B, that is negative 0.322. Now, the work is easy. We know our variables already. So which means y is now equals to a is 100 multiplied by x. X is 8. And raised to power b, which is minus 0.322. If we press that on the calculator, y becomes 51.19 hours. So what we're saying is that the average time to produce 1 unit in a group or in a team or in a batch of 8 is 51.19 hours per unit. That's what we're saying. So which means the total hours would just be equals to 8 multiplied by 51.19. And if you do that, that will give us a total hours of 409.5 hours. And let's see what we have when we did it manually for 8. You see, we got something very close, 409.6. So you can see that the equation works, and it's faster to use the equation, but the table is just there to simplify the understanding for you. Let's also use it to find out what if we are asked to find the time for third unit. So which means only 1 unit, but the third one. So you have produced number 1, you've doubled to number 2, but now normally we'll go to number 4 in our table, but the advantage of the formula is you don't need to double to calculate your number of hours. Let's say you want to find just for the third item. We're still going to use the formula, right? And first thing that we have to do for us to know how long it's going to cost for the third item alone, we need to first of all find the cumulative for a batch of 3. So which means the only way to get this is to get the average time per unit in a batch of 3, multiply by 3, and get the average time for batch of 2, multiply by 2 to get the total cost of 2. Then the difference will definitely be the time spent on the third item. This is what I'm saying. For this, we need to go through a few steps. Step 1, we need to get the cum hours for 3 units. And the way to do that is to apply the formula, which will give us the average per unit in a batch of 3. That will be equals to 3 multiplied by, that will be A will remain 100, remember, times X is 3. Then our B remains our B of minus 0.322. Put that on a calculator. That will give us Y, that is equals to 70.2. So this is per unit. So which means the batch of 3, the average time per unit is 70.2. So which means the total, which is the cum, will be equals to 70.2 times 3. And that will give us 210.6. So now that we have this, we need to do for the number of units just before 3, and that will be 2 units, so that we can get the extra time of that third unit. So 2 units, we need to do the same thing. And for 2 units, we also say Y equals to 100 times 2 raised to power minus 0.322. So let's see what this will be on the calculator. So 2 raised to power 0.0322 in second. That's 0.7999, that's like 80. Then multiply by 100, that equals to 79.99. So approximately we can say this is 80 actually. So cumulative total, because this is per unit in a batch of 2, right? So cumulative hours will be equals to 2 times 80, and that will be 160 hours. So if it takes 160 hours to manufacture 2 and 210 hours to manufacture 3, then the third unit will have taken, so third unit hours only would have taken 210.6 minus 160. Yeah, 210 minus 160, and that is giving us 50.6. So which means the third unit alone would have taken 50.6 hours. All of that, all we've done is to work it out in units, but doesn't mean that all the time you will always have it in units. Sometimes they give you in batches as well, but it's the same principle, the same understanding.